Welcome to today's deep dive. We are so glad you're joining us. So let me ask you a question. What if I told you that the absolute hardest part about going to space has almost nothing to do with rocket science and, everything to do with pouring a slab of concrete?
Yeah, it sounds completely counterintuitive, right? Because, our eyes are naturally drawn upward. We focus entirely on the vehicle, the sheer physics of escaping gravity, the fire, the thrust, all of that.
Right. But if you actually want to understand the modern commercial space economy, you kind of have to force yourself to look down, because before any of those billionaires in flight suits can ignite their engines, someone had to perform this massive regulatory miracle just to establish the ground they're leaving from.
Exactly. The ground itself is the real hurdle.
And that is our mission today. We have our hands on a highly detailed 2026 technical report prepared by Arsenal and Space Rising. It's basically an exhaustive look at FAA launch and reentry site operator licensing. Specifically, we're translating Title 14 of the Code of Federal Regulations Parts 420 and 433 into a clear roadmap.
Which I know sounds like an incredibly dry set of numbers. But these regulations are, well, they're the invisible infrastructure of the space age. They dictate the literal physical boundaries of our future in space.
Yeah, so whether you're an infrastructure nerd or, a prospective investor trying to figure out where to park your capital, or just insanely curious about what it actually takes to build a spaceport in a blank slate state like Arizona, we are going to reveal the hidden hurdles of this whole industry.
It's a fascinating landscape.
Okay, let's unpack this. Because right out of the gate, the very first section of this report completely shatters the biggest illusion about what a spaceport actually is.
It really does. There's this fundamental misunderstanding in the public, and frankly, even among some institutional investors, about what an FAA site license actually permits you to do.
Wait, institutional investors get this wrong too.
Oh, absolutely. When a facility goes through the grueling process to receive a site operator license under Part 420 for launching or Part 433 for reentry, that license does not authorize you to launch or land a single rocket.
I have to pause you there because I read that line in the report like 3 times. You spend tens of millions of dollars, maybe hundreds of millions. You navigate federal bureaucracy for years to build a spaceport, and the piece of paper they finally hand you doesn't legally allow you to fly anything.
Not a single thing.
Oh.
No.
Wow.
Yeah, the site license only authorizes the operation of the facility itself. To actually put a vehicle in the air, well, a vehicle operator has to separately obtain a Part 450 vehicle authorization. The regulatory framework is completely bifurcated.
Bifurcated, meaning split in two.
Right. The FAA treats the facility and the vehicle as two entirely distinct legal and operational entities.
So it's like spending millions to build a state-of-the-art toll highway. The government gives you the permit to operate the highway, but that piece of paper doesn't give you the right to actually drive a car on it. You still need a separate driver's license and vehicle registration for every single car, which in this case would be that Part 450 license.
That is a perfect way to look at it. And if we connect this to the bigger picture, this bifurcated system isn't an accident. It's a very deliberate strategy by the FAA.
How so?
Well, think about the lead time required for infrastructure. A state or a private company needs to secure land, issue municipal bonds, build the physical pad, long before a company like SpaceX or Blue Origin finalizes their next-generation rocket design.
Oh, I see. So the pad has to exist first.
Exactly. This site-first, vehicle-later model allows the facility to be built while legally delaying the highly specific environmental and safety reviews for individual rockets until those rockets actually exist and are, ready to fly.
Yeah, and you see this play out in the case studies from the text, right? Like places like the Space Coast Regional Airport in Florida or the Spaceport Camden project in Georgia.
Precisely. If you look at the FAA's own environmental decision documents for those sites, they explicitly state that future vehicle operators will need their own separate subsequent environmental analyses. Getting the site built just means you've opened the front door.
Right.
It doesn't mean anyone is allowed to walk through it yet.
Which brings us to the obvious next step in this roadmap. If Part 420 is just the license to legally operate the launch pad, what does the FAA actually demand from you to grant it? Because when you dig into the anatomy of launch site section of this report, the safety metrics they require are incredibly intense. You aren't just drawing a map of your property.
Not even close.
Yeah.
The FAA requires a highly prescriptive safety case. An applicant has to mathematically map out incredibly specific debris dispersion radii and flight corridor impact areas.
Debris dispersion, meaning where the pieces fall.
Yes. You're essentially calculating exactly where pieces of a rocket would fall if the vehicle experiences a catastrophic failure at different altitudes.
And there's a hard statistical threshold for that, right?
Yeah.
The report mentions an expected casualty rate.
Yeah, and this is where the math gets very real. The FAA dictates that the estimated collective expected casualty to the public cannot exceed 1 times 10 to the negative 4.
Meaning the statistical probability of a single casualty, like someone getting hurt or worse, cannot be greater than 1 in 10,000 for any given launch.
Correct. But achieving that statistical margin requires physical space. So on top of flight corridors, the operator has to submit a comprehensive explosive site plan using what the report calls quantity distance principles. And that's specifically for Division 1.1 and 1.3 explosives.
Okay, let me push back on this because those terms sound like dense bureaucratic jargon. What actually are Division 1.1 and 1.3 explosives? And, I mean, isn't quantity distance just a fancy term for standard industrial zoning?
That sounds like it, yeah.
Right. If you're building a massive chemical plant or a fertilizer factory near a populated area, you have hazardous materials too. Why is a spaceport treated differently?
I'm really glad you asked because the distinction is vital. Division 1.1 refers to mass detonating hazards. So think of the immediate concussive blast of something like TNT.
Okay, a huge boom.
Right. And Division 1.3 refers to mass fire hazards, which is exactly what a massive solid rocket motor is. The physics of a launch failure are just uniquely violent compared to typical industrial accidents.
Because it's not just a spill.
Exactly.
Yeah.
At a chemical plant, a spill or a fire generally has a localized, somewhat predictable spread. With a rocket, you are dealing with hundreds of thousands of pounds of highly volatile propellants that are engineered to release massive amounts of energy instantaneously.
So if it fails, it doesn't just burn. It basically acts like a bomb.
It does. And the original final rule establishing Part 420, which was published back in October of 2000, heavily emphasized that these explosive siting frameworks are not just zoning laws. They dictate the literal physical distance required to keep 3 specific things away from the public.
What are the 3 things?
The concussive blast wave, the intense thermal radiation, and the fragmentation, the heavy metal shrapnel of an exploding rocket. Quantity distance principles mean that the larger the quantity of explosive material you have on the pad, the exponentially greater the physical distance to your property line must be.
Wow.
Yeah, you are mathematically proving to the FAA that if the worst happens, the public is physically too far away to be touched by the physics of the explosion.
That makes total sense. You're translating pure, unforgiving physics into legal property boundaries.
Yeah.
But as the report points out, launching a rocket is only half the battle. Because if a site wants to welcome vehicles back from space, the entire regulatory framework shifts.
Entirely, yes.
We leave Part 420 behind and move into Part 433 for reentry sites.
Yeah.
Now, the report notes that the regulatory text for Part 433 is actually much shorter than Part 420. But functionally, it seems like a much bigger headache to actually execute.
Oh, it is incredibly complex. Just think about the difference in physics. With a launch, the vehicle is sitting perfectly still on your concrete pad. You control the exact starting point. With a reentry, you're dealing with a vehicle coming in from orbit, traveling at thousands of miles per hour through the upper atmosphere, trying to hit a specific patch of Earth. The overarching golden rule of Part 433 is containment.
Containment. And the report specifically calls out the 3 sigma footprint. Here's where it gets really interesting, because a 3 sigma footprint is a statistical bell curve.
Yeah.
It basically means you have to mathematically account for 99.7% of all statistical variables during a landing. So if you're the site operator, you have to prove that 99.7% of the time, that spacecraft is going to land entirely within your property lines.
Exactly.
It's like dropping a dart from a commercial airliner and guaranteeing it hits a specific drink coaster on the ground, accounting for every single gust of wind, every slight atmospheric density change, every tiny computer guidance error.
That is a brilliant way to visualize it. And what's fascinating here is what happens when you try to apply that 99.7% certainty to the real world. The report brings up a highly illuminating case study, the Huntsville International Airport in Alabama.
Which is an active commercial airport.
It is, and right now, remarkably, that is the only active FAA-licensed reentry site in the country.
You have regular passenger planes flying in and out of there all day. How on earth do you manage that airspace?
With extreme, highly disruptive caution. According to the FAA's public briefings on the Huntsville license, maintaining that massive safety footprint means that when a returning spacecraft is scheduled to land, Both of the airport's commercial runways might have to be completely closed during a temporary flight restriction.
So you have to literally clear the skies.
You do.
And it doesn't end when the spacecraft touches down, right?
It doesn't. Once that vehicle is on the runway, it doesn't just taxi over to a passenger gate like a Boeing 737.
Yeah, imagine passengers looking out the window at a spaceship.
Right. But no, it might sit out there on the runway for hours. These vehicles often use highly toxic, hazardous residual propellants like hydrazine for their orbital maneuvering thrusters. So before anyone can approach the craft, hazardous materials teams have to grain those systems and render the vehicle safe.
So just picture this. You could have commercial passenger flights circling in a holding pattern, burning jet fuel, while a charged spaceship sits in the middle of the tarmac getting defueled by people in hazmat suits. The operational disruption is staggering.
It is, which is exactly why Part 433 relies so heavily on the operational coordination between the site operator and the vehicle operator. You have to prove to the FAA that you can handle the airspace integration, control public access, and execute a prompt mishap response without jeopardizing the safety of the surrounding community.
Okay, so we've established this massive mountain of physical requirements. You have blast radius physics for the launch pad under Part 420 and 99.7% containment zones for reentry under Part 433.
Right.
The next logical question for anyone looking to build a spaceport is, well, how long does it take to prove all of this to the government? And the report highlights a very pervasive myth in the commercial space industry regarding the FAA's timeline for approving these site licenses.
Yes, the famous 180-day statutory review period.
Right. You hear 180 days and you think, great, 6 months and we have a spaceport. We can start breaking ground.
Sure, it sounds fast.
But this report throws cold water on that assumption immediately. It clarifies that the 180-day clock only starts after an application is completely finished, formally submitted, and officially accepted by the FAA for evaluation. The real trap, the thing that actually eats up the calendar and the budget, is NEPA, the National Environmental Policy Act.
Oh, NEPA is the true schedule driver of the commercial space economy. The FAA's environmental guidance is ironclad. A NEPA finding is required before they can authorize any spaceport operations. It is not collateral paperwork that you do on the side.
It's the main event.
It is a foundational part of the application package itself. You cannot even start that 180-day clock until your environmental homework is done.
But let me ask you something that seems obvious. If you want to save time and bypass a lot of that environmental groundwork, shouldn't you just build your spaceport at an existing airport? I mean, think about it. You already have runways. You already have aviation infrastructure. The land is already cleared, paved, and historically zoned for noisy flight operations.
Yeah.
Wouldn't that fast-track your NEPA review?
It seems entirely logical, but the report completely dismantles that assumption. When you try to build a spaceport at a federally obligated airport places highlighted in the text, like Houston Spaceport or Spaceport Colorado, you don't bypass the bureaucracy. You actually trigger a second parallel review track.
Oh, wow. You essentially double your red tape.
Precisely. Because it's an airport, you suddenly have to deal with the FAA Office of Airports, which operates completely separately from the Commercial Space Division.
Two different silos.
Exactly. So now you have to update complex airport layout plans. You have to handle Part 139 implications, which, for context, is the federal regulation that governs the daily safety operations of commercial airports.
What does that cover?
Part 139 dictates how fast a crash rescue truck has to respond to an emergency, the type of firefighting foam they use, runway sweeping protocols, things like that. Integrating a highly explosive space vehicle into a Part 139 environment requires custom safety waivers and entirely new emergency response plans.
That sounds like a nightmare. And the report lays out a fantastic table of historical case studies that really brings these timelines into perspective. For instance, look at Cecil Field in Florida, which was an early horizontal launch airport model. They managed to navigate the environmental process by securing an EA and a FON-SI.
Let's clarify those acronyms for a second. An EA is an environmental assessment. It's a less intensive study. If the EA concludes that your project won't severely damage the environment, the FAA issues a FON-SI, a finding of no significant impact.
Right. And by getting that EA and FON-SI, Cecil Field got their license in about 17 months, which is, reasonably fast for federal infrastructure.
Right.
But the report contrasts that with the ultimate cautionary tale.
Spaceport Camden in Georgia.
Oh, Spaceport Camden is a jaw-dropping timeline. It took 6 years.
6 years. 6 full years from their initial notice of intent to finally getting a license. And the reason comes down to the environment and the public. Because of its location near pristine coastal areas, Camden couldn't just do a simple environmental assessment. They were forced into a full environmental impact statement, or an EIS.
Then an EIS is a fundamentally different beast.
Entirely. An EIS is an exhaustive, multi-year study of every possible impact. It requires massive data collection, biological surveys, and mandatory public hearings. During that EIS process, the Spaceport Camden project generated over 15,500 public comments.
15,500. And legally, the federal government has to process and address the substantive ones. Why was there so much pushback?
Well, it came down to a combination of environmental and historical concerns. You had Cumberland Island nearby, which is a protected national seashore. People were concerned about the noise impact on wildlife, the risk of rocket debris falling on residential areas, and critically, the cultural resource consultation under Section 106.
Let's define Section 106 for a second, because that comes up again later.
Section 106 of the National Historic Preservation Act requires federal agencies to evaluate how a project will affect historic properties and tribal lands. At Camden, the public and historical preservationists were deeply concerned about the physical and auditory impact of rockets on historic sites. It just proves that building a spaceport is not merely an engineering challenge. It is a massive exercise in navigating public perception, political opposition, and historical preservation.
Which provides the perfect logical bridge to the specific geographic focus of this entire technical report, which is the state of Arizona. Because if you look at how difficult it is to build in Florida or Georgia, you have to wonder what happens when a brand new state tries to enter the space race.
Arizona is a fascinating case study. If you look at the FAA's current listing of spaceports by state, Arizona is conspicuously absent.
They are an absolute blank slate, 0 licensed launch or reentry sites.
Right, which means any prospective applicant in Arizona isn't just building a physical facility. They are tasked with building the entire regulatory pathway and stakeholder ecosystem from scratch. There is no precedent there. And the report lays out a very specific, heavily researched, high-risk matrix for attempting this in Arizona.
Let's look at that risk matrix. If I'm an investor looking at a map of the Arizona desert, I mean, it looks wide open. What are the specific landmines I'm going to step on?
First, just like we saw in Camden, you have the Section 106 review. Arizona has a deep, rich history of tribal lands, ancient cultural sites, and historic artifacts. Any federal licensing action, including an FAA spaceport license, triggers mandatory tribal and historic consultations.
And if they object?
If your proposed flight corridor passes over a sacred tribal site, you are looking at significant delays, required mitigation, or outright denial if an agreement can't be reached. But the truly unique, definitive, high-risk hurdle for Arizona involves military airspace conflicts.
Because Arizona is absolutely packed with military bases, aviation testing grounds, and Department of Defense training ranges.
Exactly. The report highlights that Arizona state law explicitly requires planners to consider military and range influence areas. The sky above Arizona isn't just empty air. It is a complex 3D geometry of military operations areas, or MOAs. You have fighter jets conducting high-speed maneuvers. You have weapons testing. You have classified DoD operations.
And you can't exactly ask the Air Force to pause their national security training schedule for a week just because you have a commercial rocket sitting on a launch pad waiting for good weather.
Exactly. Deconflicting a commercial space launch, which requires shutting down massive columns of airspace for safety from critical military training routes, is a massive, highly political front-end site selection issue. If your proposed spaceport infringes on DoD airspace, the military will object, and the FAA will not grant the license.
So what does this all mean? If you're looking at this as a taxpayer, a local politician, or an investor, what does this actually mean for you? It means that building a spaceport in a place like Arizona isn't just a simple real estate play. You can't just find a stretch of cheap, empty desert, buy it, and start pouring concrete.
Definitely not.
You are stepping into a regulatory minefield. You have to successfully navigate incredibly complex military airspace geometries. You have to build deep, respectful relationships with tribal and historic stakeholders from day one. And you have to be perfectly calibrated in your environmental approach to avoid the kind of public opposition trap that stalled Spaceport Camden for 6 agonizing years.
This raises an important question, really, for any new state looking to enter the commercial space arena. How do you balance the undeniable, futuristic economic draw of hosting a commercial spaceport against the harsh reality of this regulatory burden?
It's a huge trade-off.
Because this Arsenal and Space Rising report does not sugarcoat the reality. The near-term implementation risk for a new launch site in a state like Arizona is definitively categorized as high regarding both schedule delays and operational complexity. It requires an incredible amount of capital, immense patience, and unwavering political will before you even see a single cent of return on your investment.
It is a monumental undertaking. And it really brings this entire conversation full circle. We started by looking at the concrete, and we found that building a spaceport is this incredibly high-stakes blend of disciplines you wouldn't normally put in the same sentence.
Yeah, quite a mix.
You have explosive quantity distance blast math. You have 99.7% statistical reentry containment zones. You have the parallel bureaucracy of commercial airport daily safety. And you have this intense multi-year environmental and historic scrutiny. And the ultimate irony at the end of all of that, the license to build a facility still doesn't even grant you the license to fly the rocket.
It's a sobering reality for the commercial space industry, but it's an absolutely necessary one. We are dealing with unprecedented kinetic energy and hazardous materials. The FAA's labyrinth of rules exists to ensure that as we commercialize the ultimate frontier, we don't sacrifice public safety on the ground to achieve it.
It absolutely is. And as we wrap up this deep dive, I want to leave you with a final thought to mull over. It's something that isn't explicitly spelled out in the text, but it directly builds on everything we've just discussed regarding the sheer friction of this process. Consider this. If every single local spaceport requires bespoke, multi-year environmental tiering, customized expected casualty models dialed down to the 1 in 10,000 margin, and massive tribal and military airspace deconfliction, how can the commercial space economy ever truly scale to operate like the modern airline industry?
That is the big question.
Right. We talk about a future of daily flights to orbit, but are we destined, because of the sheer physics involved, to treat every single trip to space as a highly customized regulatory miracle? Keep exploring that idea. We hope you enjoyed diving into this with us, and as always, stay curious.